introduce the data science part C, first internal test, data pre-processing for feedback analytics. Student faculty feedback data may suffer from issues like accuracy, completeness, and consistency. Discuss each issue in this context, that is, missing survey responses, contradictory ratings, propose two other dimensions of data quality relevanting to learning analytics. First, accuracy, the reality check, that is, does the data correctly reflect the real world value? Issue noise or errors in entry. Example, a student enters the semester percentage as 950 instead of 95.0, or a student selects strongly agree for satisfaction but writes terrible experience in the text box. Contradiction. Second, completeness, the missing check. Definition is all required data present. Issue null values or empty fields. That is, example, a survey is submitted but the course ID or student age field is left blank. This makes it impossible to group the data later. Consistency, the standard check. Definition is the data format uniform across the entire database. Issue different coding schemes or formats. The example, student A enters date as DDMMYYYY. Student B entered date as MMDDYYY. Student C writes department as CS. Student D writes COMPSCI. Two proposed dimensions. Four-dimensional definition was the data collected effectively at the right time. Context feedback for a course collected 6 months after the exam is useless because students forget details. It must be collected during or immediately after the course. Fifth, believability, trustworthiness. Definition, can we trust the source of the data? Context, did a student write a script to spam the feedback form with 100 fake reviews? We need to verify the user's identity to ensure the data is believable. Handling missing student feedback values. Discuss approaches such as ignoring tuples, manually filling with constants, mean, median, mode, imputation, class-specific imputation, or most probable value methods. Scenario, a student submits a feedback form but leaves the rating 1 to 5 blank. How do we fix it? Ignore the tuple deletion method, delete the entire row. When to use, only when the class level the main thing you are predicting is missing. Drawback, very wasteful. If you delete every student who missed the one question, you might lose 50% of your data. Fill manually. Method, a human looks at the record and fills it in. When to use, small sensitive database. Drawback, impossible for big data, thousands of students. Fill with a global constant. Method, replace all empty spots with unknown or -1. Drawback, the algorithm might treat -1 as a real number, confusing the math. Mean, median, mode, imputation, central tendency. Method, fill the empty spot with the average mean rating of all students. Pros, simple and safe. Cons, it reduces the variance, makes everyone look the same. Class specific imputation method, be smarter about the average. Example, if a computer science student misses a rating, fill it with the average rating of other computer science students, not the whole college. Pro, much more accurate because it respects the subgroups. 6. Most probable value prediction method, use a machine learning algorithm like regression or decision tree to predict that the student would have rated based on their other answers. Pros, the most accurate method. Cons, the most complex to implement. Consider the feedback rating same as in question 2. Smooth the ratings using bin means with bin depth 3 illustrate steps. Suggest ways to detect outliers, that is abnormally high or low satisfaction. Discuss other methods for data smoothing. Smoothing with bin means bin depth is equals to 3. Goal to remove noise, random fluctuations from the data. Data from Q2 sorted. We have a data set of some numbers, and step 1 is to partition into bins. Depth 3. Divide the sorted list into buckets of 3 each items. Bin 1, bin 2, bin 3. So step 2 is to calculate mean. Mean of bin 1, mean of bin 2, mean of bin 3. Smooth replace values with mean. Step 3. Now we have detecting the outliers by box plot IQR method. Calculate IQR Q3 minus Q1. Any value higher than Q3 plus 1.5 into IQR is an outlier. Any value lower than Q1 minus 1.5 into IQR is an outlier. Z-score method. Calculate the Z-score for every point. If Z-score is greater than 3 or Z-score is smaller than -3, it is an outlier, statistically highly improbable. Scatter plot. Plot the data points visually. Strong positive, so it will be rising. Any point that is far from the main cluster is an outlier. See, other data smoothing methods would be bin median. Replace the bin values with the median value, middle value of the bin. This is better than the bin if the bin has an outlier. Bin boundaries. Replace the bin values with the closest boundaries, the min or max of that bin. Regression. Fit the mathematical equation line to the data to smooth out the bumps. Now in a data integration for MCA and MTech analytics, discuss schema integration, handling redundant data, that is duplicate entries from the multiple surveys and resolving conflicts in values. Definition: merging data from multiple disparate sources, that is library database, exam portal, placement cell, into a coherent data store data warehouse. First is to schema integration and entity identification problem. Issue: different database use different names for the same thing. Example: the exam database uses student ID, but the placement database uses roll number. Solution: metadata analysis. We must map these attributes together so the system knows student ID is equals to roll number. Handling redundant data. Issue duplicate or derived data significantly increases storage and slows down mining. Types: duplicate entries, the same student recorded twice because of a typo in the name. Derived attributes: storing both date of birth and age. Age is a redundant because it can be calculated from date of birth. Detection: for nominal data, use chi-square. To check correlation for numeric data, use Pearson correlation coefficient. Its correlation is 1.01. Attribute is redundant. Resolving data value conflicts. Issue: the source is the same, the attribute is the same, but the value is different. Course different scales. One department records marks out of 100, that is 85. Another uses CGPA, that is 8.5. Outdated data. One database has the student's old address, another has the new one. Solution: standardization rule. Convert all scores of percentage and trust rules, that is always trust the registrar's database over the library database address. Discuss normalization method, which is min-max normalization, Z-score normalization using mean, absolute deviation, Z-score normalization, and decimal scaling. Normalization: we use normalization to scale numeric attributes to a common range so that large numbers like salary don't dominate small numbers like age during distance calculation, that is KNN. Min-max normalization goal is to rescale the data linearly to fix range, usually 0, 1. Formula will be putting V minus VA VA max V max A minus max min. It can be find out through the window to viewport method. Pros preserve the relationship exactly. Cons very sensitive to outliers. 1 millionaire ruins the salary scale for everyone. B Z-score normalization standardization. Goal is to scale data to the mean mu is equals to 0 and standard deviation variance is equals to 1. Formula V is equals to V minus V dash is equals to V minus mu A upon में variance A. Pros handles outliers much better than min-max. Good when you don't know the actual min-max of the population. Now we have Z-score using mean absolute deviation MAD. Goal is an even more robust version of Z-score of data with extreme outliers. Formula is to V dash is equals to V minus mu A upon में SA, where SA is the mean absolute deviation 1 upon n summation of mod of V minus mu A. So pros will be reduce the impact of outliers even more than standard Z-score, and this decimal scaling goal is to move the decimal point of values of attribute A. Formula is V dash is equals to V upon 10j, where j is the smallest integer such that max V dash is mod of V dash is smaller than 1. Example, if values range from minus 986 to 812, divide everything by 1000, j is equals to 3. 986 becomes 0.986. Normalize the following faculty workload or values R per semester: 200, 300, 400, 600, 1000 using A minus D. The data R per semester is. Now step 1 is to calculate basic statistics. We have $n is 5, min 200, max 1000. Mean will find it through the formula and standard deviation by the formula. Mean absolute deviation by the formula and min max normalization range by 0 to 1 by putting it in the formula. Now we have denominator is 1000 minus 200, which is 800. So we will putting it by differencing it by the values. Now we'll find the Z-score normalization by putting the values in the formula, and Z-score using mean absolute deviation MAD formula. We have decimal scaling. Formula would be V dash is equals to V upon 10j, where we know that j moves the decimal. So we'll put the max value of it and finding out the value. Now using the feedback rating dataset, normalize the value 35 using min max normalization 0 to 1 range. Z-score normalization 0 is equals to O is equals to 12.94, and decimal scaling. Discuss which method is most appropriate and why. We are normalizing the single value V is equals to 35. We use the data set statics calculated back in question 2. So we have a min is equals to 13, max is equals to 70, mean mu is equals to 28.62, standard deviation is equals to 12.94. Now we're finding the min max normalization of 0 to 1. Formula is it, and now we'll calculate the result will be 0.386. Interpretation: the score 35 is at the 38.6% mark of the range. Z-score normalization, putting it in the formula, the result will be 0.493. Decimal scaling logic: the maximum value is the dataset is 70. This is a 2-digit number, so action will be divided by 10 की power 2 into 100 to make it less than 1. Calculation: 35 by 100, result will be 0.35. Discussion: what is best? Best method is min max normalization. Reason: student feedback is usually bounded, that is rate 1 to 5 or 0 to 100. Min max preserves this intuition. 0 means lowest possible, 1 means highest possible. Z-score can produce negative numbers, that is minus 1.5, which are confusing for a satisfaction score. Using age and productivity data from question 4, normalize both attributes using z-score normalization, compute person's correlation coefficient and covariance. Comment on whether the relationship is positive or negative. The data we have age in mean, we'll find it productivity p and we'll find the mean of it. Now normalize both attributes z-score. We convert raw data into z-score to make them comparable. Example, student 1, we have his or them, their day, age, productivity and insight. This student is very young, minus 1.69, and has very low productivity, minus 2.15. Example, student 17, age we have productivity insight. This student is older, plus 0.98, and has high productivity, plus 1.29. B, person correlation coefficient R, covariance curve. The average of the product deviations curve AP is equals to 96.5. A positive number means they move in the same direction. Now correlation coefficient formula R is equals to, will put in the formula and the result will be R is average of 0.76. Conclusion, since R is equals to 0.76, there is a strong positive correlation. Interpretation, as age increases, self-assessed productivity tends to increase. Suppose student project evaluation scores are 5, 10, 11, 13, 15, 35, 50. So we have a data set. Now partition into bin using equal frequency partitioning, equal width partitioning and clustering. We have data, n number of count is equals to 12, min is equals to 5, max is equals to 2.50. Now we'll find the equal frequency partitioning bin depth. So goal is to put the same number of items in each bin and calculation n is equals to 12. Let's create 3 bin. Items per bin is equals to 12 by 3 is equals to 4. We have bin 1, bin 2, bin 3. Note, good for handling outliers as this just sit in the last bin without stretching the scale. Now equal width partitioning. Goal is to divide the range into intervals of equal size. Calculation will put the range is equals to max minus min. So it will be 210. Let's use 3 bins with 2 by 10 by 3 is equals to 70. Now intervals, B1 is equals to 9 items, B2 is equals to 1 item, B3 is equals to 2 items. Note bad for this skewed data set. Bin 1 is overcrowded. Clustering k-mean, k is equals to 3. Goal is to group data based on mathematical closeness, similarity. So result will be cluster 1 low score, cluster 2 medium score, cluster 3 outliers. Note, this is the smallest method, smartest method. It correctly identifies that 204 and 215 are in a league of their own. Now use a flowchart to summarize the attribute selection technique for feedback analysis: forward selection, backward elimination and hybrid method. Goal is to select the most important attribute feature for our model and remove the useless noise. Forward selection, the builder approach. First, start empty set. Step 1, test every single attribute individually. Find the best one, that is CGPA, add it. Step 2, test the remaining attributes combined with CGPA. Find the best pair, add it. Repeat, keep adding the next best attribute until performance stops improvising. Flow, empty A, AB, ABC. Now backward elimination, the pruner approach. Start all attribute A, B, C, D, E. Step 1, train the model with everything. Identify the worst or least useful attribute. Second is to remove it. Repeat, keep removing the worst attribute until performance starts to drop. Flow is A, B, C, D, E, A, B, C, D, A, B, C. Now we have hybrid method, the best of both. Start can start empty or full. Step in each round, apply both rules. Add the best new attribute. Forward step, remove any attribute that has become useless. Backward step. That is all for part 3.